Welcome back. In this session, we will introduce a method called material flow analysis. At the end of this session, you should be able to understand the concept of materials flow analysis and give examples of the main elements of materials flow analysis. Materials flow analysis, MFA, has been defined as a systematic assessment of the flows and stocks of materials within a system defined in space and time, and based on the law of matter conservation, in other words, maintaining mass balance. The use of MFA helps identify and visualize the current situation, and can inform decisions related to waste management and the development of circular economy. With MFA, measures can be envisaged, outcomes modeled, and can be used as a monitoring tool to evaluate effectiveness of improvement measures taken. Typically, an MFA analysis is visualized by means of flow diagrams and Sankey diagrams where the flows are represented by arrows, which thickness is in function of the amount of flow. For instance, in this diagram you can see that 78 million tons of plastic packaging are produced per year, from which 32% leaks into the environment, 40% goes to landfill, 14% goes to incinerator and/or energy recovery facility, and only 14% are collected for recycling. We also see the source of these 78 million tons of plastic packaging. 98% stem from virgin feedstock, and only 2% are obtained from a recycled compound. With this assessment, we can now think and plan how the amount collected for recycling might be increased, or how plastic leakage into the environments could be decreased. For instance, by implementing an improved solid waste management system. Elements of an MFA are a definition of the system boundary, which delineates the space of the analysis. The time unit of the analysis needs to be defined, for instance flows per year. Then process steps are described. These receive flows use and transform the materials, and may split the flows into subsequent different flow pathways. Furthermore, there may be stocks and sinks where flows accumulate. And finally, the flows themselves, representing a certain unit of materials or substances. Material flow analysis can be conducted at a spatial level of a city. For instance, let's take this case of waste management in a city of Argentina. This contains a lot of information, so let's look at some selected aspects. The thickest arrow shows that most of the waste, around 42,000 tons per year, are collected by the municipal collection services, and this amount goes to landfill. You can also see that waste pickers, which are those that recycle waste materials, only retrieve small amounts of materials, mainly from non-households waste generators, but also retrieve material from landfills and dumps, shown by the arrows coming from landfill and dumps and going to the waste pickers. Additionally, you can see the red arrow, showing that half of the private containers are emptied into open dumps, instead of going to landfill. Based on this analysis, you can now think of improvement measures. For instance, a measure that might allow waste pickers to access the waste before it is collected by the municipal services. Material flow analysis can however be conducted for one industrial process, or in this case, for one composting site, where you can see how the composting facility processes 60 tons of waste per year, which is predominantly organic, with only 0.6 tons of non-organics. The organic fraction is then processed by composting to generate 14.2 tons of mature compost per year. From these two brief examples, you can see that materials flow analysis is a key tool in getting the overview and monitoring of circular economy, but is also key in the field of industrial ecology. It can be used to analyze a small-scale processing unit, but also large-scale systems such as cities or even aspects on a global level. That's it for material flow analysis. Let's summarize what we have seen in this session. We now understand the method of material flow analysis as an assessment method to analyze flows and stocks of materials within a system defined in space and time. MFA can be used at different levels of scale, either to assess the flows over a spatial area, a country or city, but also more specifically, to analyze a specific processing unit. This method is a valuable tool for baseline assessment, but also for planning improvements, as well as measuring and evaluating outcome of those improvements. Thank you for your attention. See you in the next session.